Good morning all. Today we will discuss about parallel RLC circuit. So we will discuss about the parallel RLC circuits. Now we will draw the Phasor diagram for parallel RLC circuit. We have drawn the Phasor diagram for the series RLC circuit, and with the knowledge we will be able to draw the Phasor diagram of parallel RLC circuit very easily. Now we can draw one simple parallel circuit excited by one alternating current source. So now if we take one example of parallel resistive circuit containing three different resistors connected in parallel, so we will get this type of circuit. Now similarly, using the three different components, that is R, L and C, we can develop our parallel RLC circuit. So we can draw like this. So where the resistor, inductor and capacitor all will be present and they will be connected in parallel to each other. Now if the Vs is the supply voltage, so Vs can drive one current which will be Is or It, total current, and it will be sending different amount of current through each element. Here we know that these currents may be same or may not, depending on the value of impedance created by each element. So the impedance created by R, say ZR, and impedance created by L, say is ZL, and impedance created by C is ZC. And now the amount of current will depend on R, L, C and omega for a particular Vs. Now we will draw the Phasor diagram for parallel RLC circuit. We have drawn the Phasor diagram for the series RLC circuit, and with the knowledge we will be able to draw the Phasor diagram of parallel RLC circuit very easily. So before going to the three element parallel circuit, it is better to understand the two element circuit, and let us draw the Phasor diagram of the parallel circuit containing two elements. So let us consider first a two element RL parallel circuit that is excited by one supply called Vs. Now here we can see the resistance and inductance are connected in parallel, and both are connected across the supply Vs. Now Vs will give some current or drive some current. That current can be considered to be Is or It, or total current. But this total current will be divided in two branches. Say this will be IR and it can be denoted by IL. That is, current through the resistor is IR and current through the inductor is IL. And now if we think about the voltage drop across the element, so we can understand the voltage across inductor can be denoted by VL and voltage across the resistor can be denoted by VR. So this will be VR. And as a rule of the parallel circuit, we know that the VR equal to VL equal to, say, V. Now we know that the voltage across R and L are same, but the current through the elements, that is current through resistor and current through inductor, may be same, may not be same. That depends on some parameters like, say, current through R and L depends on R, L and omega for a specific value of Vs. So now if we go for the phasor diagram of the circuit, we have to take the principle of reference phasor. In series RLC circuit, we learned that the parameter, that is a voltage or current, the parameter which is same for all the elements, that is better to be taken as the reference phasor. So here you can see the voltage associated with all the elements is same in parallel circuit. In case of series circuit, current was same, so that's why current was taken as a reference phasor for drawing the series phasors, for drawing the phasor diagram of series RLC circuit. But here, as the voltage is same for all the elements, we will take voltage phasor as the reference. So we will take this V, and this V will be VR equal to VL. Now for one resistive circuit, we know that the current through resistor and the voltage across resistor are in the same phase. So we will draw IR in the same direction with the VR or VL or V. And for the inductor, as we know, the current lags behind the voltage across inductor by an angle pi by 2 for a pure inductor. So we will consider that these elements are pure elements. So here we will draw one current, that is IL, and the phase displacement will be pi by 2 from the voltage, and it will be also obtained after rotating in the clockwise direction, because clockwise rotation indicates the lagging condition. So this is the phasor diagram of two elements parallel circuit, that is R and L, so RL parallel circuit, and the current phasor, which is indicating the total current or resultant current, will be obtained in this direction, and that will be denoted by IS or IT. Now IT will have one phase angle, so IT will have one phase angle, that will be phi, and this phi is called the phase angle phi, phase. So phase angle is phi, and you can see that this phasor is lagging behind the voltage. So in which circuit current lags? In inductive circuit. So this circuit is inductive circuit, and the performance or behavior will be like one inductive circuit. But this inductive circuit definitely is not the pure inductive circuit, because one R is there. So one R is there, so that definitely this angle will not be the 90 degree, this phi. So as soon as the circuit will be pure inductive circuit, this phi will become 90 degree. So now let us consider another circuit, another parallel circuit which contains one resistor and one capacitor in parallel, and we will draw the phasor diagram of this parallel circuit also. So it will be C, resistance is denoted by R, current through resistance will be IR, current through capacitance will be IC, total current will be IS or IT, and the supply will be Vs. Now we will draw the voltage reference. So this will be V. Now the voltage across C is considered to be the Vc as shown in this figure, and voltage across resistor will be also denoted by VR as we have already done in the previous case. So now this V will be VR equal to Vc, and for the resistive circuit, as current and voltage are always remain in same phase, so we will draw the IR which will be in same direction with VR, and for the Vc as the current leads, so for the capacitive circuit as the current leads, so definitely the IC will be drawn as a leading phasor compared to the voltage V, and as the capacitor is considered to be pure here, so we will get a phase displacement of pi by 2 from the voltage, and this will be considered to be the leading current. And now for the resultant current, we will draw this phasor, and we will be denoting this phasor as IS or IT, and the angle between this voltage V or VR or Vc and the current, resultant current, is a phi. So this angle will be phi, and this angle is the phase angle, and this angle is called the leading phase angle because the current is obtained in an anti-clockwise position. So the current IS is found after rotating in anti-clockwise direction. So that's why this total current or resultant current is found as a leading phasor over the voltage, and that's why this circuit is called a capacitive circuit. But it is not a pure capacitive circuit because resistance is there, so the circuit has the effect of R as well as the effect of C. Now depending on the value of R, value of C and value of omega, the phase angle will be decided, as we have already discussed in the series RLC phasor diagram circuit in the series RLC circuit classes. So similarly, in case of the inductive circuit also, the phase angle will depend on the value of R, value of L and value of omega. So I think the phasor diagram of two element parallel circuit is clear to you.